Good morning. We need to find the basis for the eigenspaces of the matrix A. So for that we need to find first the eigenvalues. So this is the matrix A given to us, and the characteristic equation of A is the determinant of lambda I minus A to be equal to 0, where I is the identity matrix, the 3 by 3 identity matrix. And now writing the elements. What is the first element in the first row? Okay, here I am having lambda I. That means it is lambda 1 0 0 0 1 0 0 0 1, the identity matrix, minus the given matrix A. So when lambda is multiplied with this, we are getting lambda 0 0 0 lambda 0 0 0 lambda, and this matrix is subtracted with the given matrix A, right? So writing the first element, lambda minus 3, that is lambda minus 3. Then 0 minus minus 2, that becomes 2. Then 0 minus 0 is 0. And then 0 minus minus 2 becomes 2. And then lambda minus 3 and 0 and 0 and 0 and lambda minus 5. I hope it is very clear to you. So this is equal to 0. Solving this determinant, we get lambda minus 3 into cross multiplying these two. So this is lambda minus 3 into lambda minus 5 minus 0, right? Then minus 2 cross multiplying these two. So this is 2 into lambda minus 5 minus 0. And then plus 0 cross multiplying these two, that is 0, right? Equals to 0. So I am getting lambda minus 3 whole square into lambda minus 5 first. So this is lambda minus 3 whole square into lambda minus 5. And then minus, this is 4 times lambda minus 5. So minus 4 times lambda minus 5. And now taking lambda minus 5 common, we get lambda minus 3 whole square minus 4 equals to 0. And this is lambda minus 5 into, opening the square, this is lambda square plus 9 minus 6 lambda minus 4 equal to 0. 9 minus 4 is 5. And when making the factors for this, we get lambda minus 1 into lambda minus 5 equals to 0, or lambda minus 5 whole square into lambda minus 1 equals to 0. So we are getting two values, lambda equal to 1 and 5. So these are the two eigenvalues we got. The eigenvalue lambda 1 equal to 1 is of multiplicity. What is the power over here? It is 1. So eigenvalue lambda 1 equal to 1 is of multiplicity 1. And the eigenvalue lambda 2 equal to 5 is of multiplicity 2. The power is 2 over here. And now we are going to find the corresponding eigenvectors for these two eigenvalues. Now the eigenvector corresponding to lambda equal to 1 is, so capital X equal to x1, x2, x3. This is an eigenvector of A. So this is the eigenvector of A corresponding to lambda if and only if X is non-trivial solution of homogeneous equations. Lambda I minus A into X equals to 0. So we need to solve these equations to get the eigenvectors for the corresponding values of lambda. So first we are having lambda 1 to be equal to 1. So just put the value of lambda 1 to be equal to 1 over here. So we get, okay, already we have found lambda I minus A to be equal to this matrix, right? So just we need to put lambda 1 equal to 1 in place of lambda. So we get 1 minus 3, that is minus 2, 2, 0, 2, then minus 2, 0, 0, 0, minus 4. So we have here minus 2, 2, 0, 2 minus 2, 0, 0, 0, minus 4. So this is your lambda I minus A. And now writing X in the format x1, x2, x3, it is having the 3 elements, and 0 in the column vector. Now to get the first equation, multiply this minus 2 with x1 plus multiplying this 2 with x2 plus multiplying this 0 with x3 equal to 0. This is the first equation. So this is minus 2x1 plus 2x2 plus 0x3 equals to 0. So from here we get minus 2x1 plus 2x2 equals to 0, or it is minus x1 plus x2 equals to 0, which can be written as x1 equal to x2. So from the first equation we are getting this relation. This is the first equation. And now the second equation. So likewise the second equation becomes 2x1 minus 2x2 plus 0x3 equals to 0. So that is 2x1 minus 2x2 equals to 0. So that is x1 minus x2 equals to 0. That becomes x1 equal to x2. Again the same relation. And the third equation we get, this is 0 into x1 plus 0 into x2 plus minus 4 into x3 equals to 0. So from here we get x3 to be equal to 0. So we have got two relations, x1 equal to x2 and x3 equal to 0. If x1 equal to x2, let me give the value x1 to be equal to t. So x2 is also having the value t. T is any real number. T is belonging to the set of real numbers. So now writing the eigenvector for this, we have got the values of x1, x2 and x3. So x1 is t, x2 is also t and x3 is 0. Taking t outside, we get 1, 1, 0, where t is belonging to the real numbers. So this is your eigenvector. And now finding the eigenspace E lambda 1, that is equal to, just write this column vector in this format, which is its basis, right? Next, let's work on the eigenvalue lambda 2 equal to 5. So for that, we must write the homogeneous equations of this format. This is your lambda 2I minus a, and this is your x, and this is 0. So lambda 2I minus a, that means now we have to put lambda equal to 5 in this matrix, right? This time I'm having lambda 2 that is equal to 5. So 5 minus 3, 2, 2, 0, 2, and then again 2, 0, and 0, 0, 0. So I'm having here 2, 2, 0, again 2, 2, 0, and then 0, 0, 0. And x, x1, x2, x3, and 0 as in the column vector like this. Solving the three equations, first equation is 2x1 plus 2x2 plus 0 equal to 0. So it is 2x1 plus 2x2 plus 0 equals to 0. Second equation, 2x1 plus 2x2 plus 0 into x3, that is equal to 0. So this is 2x1 plus 2x2 plus 0 equals to 0, the same. And the third equation, 0 into x1 plus 0 into x2 plus 0 into x3, that is equal to 0, that is 0. And third equation becomes 0 into x1 plus 0 into x2 plus 0 into x3 equal to 0. So here we get 0 into x3 to be equal to 0. So x3 into 0 means whatever value I put for x3, let that be equal to s, where s is belonging to the set of real numbers. Any value belonging to the real number, if I multiply that value with 0, I will be getting 0. That means x3 equal to s is satisfied for all values belonging to the real numbers, right? So I am taking the value of x3 to be equal to s, and from these two equations I will be getting 2x1 plus 2x2 equals to 0, that is x1 plus x2 equal to 0, which means x1 equal to minus x2. So I am getting this relation. If x1 is equal to minus x2, if I give x1 the value to be equal to t, the value for x2 becomes negative t. So now I am having these three values, x1, x2, x3. So eigenvector is of the format x1, x2, x3, that is t minus t and s. Let's have the addition of these two. T into 1 minus 1 0 and plus s into 0 0 1. Can I write like this? If we multiply t with this and s with this and adding these two, we will be getting back our vector this. Now since these two are linearly independent, right? The first vector and the second one which we have got, these are linearly independent, and because these are linearly independent, they form the basis for the eigenspace E lambda 2. For lambda 2 equal to 5, we have solved this. So the eigenspace is having the basis 1 minus 1 0 and 0 0 1, two bases. So this is how we got the basis for the eigenspaces for the two values of lambda, that is for the two eigenvalues, lambda 1 equal to 1 and lambda 2 equal to 5. Okay, thank you. Stay blessed.